In lesson 9, we are going to take a look at investigating equations of lines. So we've looked at circles, we've looked at parabolas, and now we are going to look at lines. So this starts on page 68 in your workbook. So go ahead, take a look at page 68, and it gives you a graph of a line with 2 points labeled, and it tells you that the slope of the line pictured is 8/15. So explain how you know this to be true. So write down some different things that you remember about slope and explaining how this slope is 8/15. Then you can come back to the video. All right, so a couple of things that you might have remembered about slope to help you explain how we know that this slope is in fact 8/15 is you could have remembered maybe the words rise over run, and maybe you drew on this rise over run slope triangle with a vertical line and a horizontal line. Then taking a look, we don't have the grid background to just be able to count the rise and count the run. And so we kind of thought of the vertical movement here as the vertical distance, and then the run as the horizontal distance. And you can connect this back to what we've been doing with circles and parabolas. So the horizontal distance, remember, is where we can subtract these x coordinates to figure out how wide this is. So we can go 5 minus the -10, and 5 minus a -10 is like 5 plus 10, and that would give us that 15 for our run. Okay, so on the bottom, getting 15. And then looking at the vertical distance here as the subtraction of our y values. So we've got 2 all the way down to -6. And so then we can go ahead and subtract those to get that vertical distance. So 2 minus a -6, which minus a minus would be a plus. And that 2 plus 6 giving us 8 for the rise. So then the slope being our vertical distance over our horizontal distance, so 8/15. So then if we flip the page and we go to activity 9.2, we have this image of a line shown here. And they're telling us that the slope of the line is 2. So they're giving that to us, that we know that the rise over run here is 2. And then we also see these 2 points labeled. So let's write an equation that would connect those two. So go ahead and try and connect those two with an equation, knowing that the rise over the run is equal to 2. And then come back to the video after you've tried. All right, so I'm just going to write that out, what I just said. So if we know that the rise, which was our vertical distance, okay, so what we just looked at is our vertical distance, or our rise, divided by our horizontal distance, or our run, is equal to our slope. So let's just plug in the things that we know here. So how do we find that vertical distance again? Oops, let me change colors here. So our vertical distance, again, we subtract our y values. So to find this vertical movement here, we would do y minus 3. And then to get our horizontal distance, so this horizontal movement, remember, we subtract our x's. So in this case, our x minus 1. And then we know that that's the slope. So in this equation, our slope is equal to 2. So that would be an equation we could write to say that the slope between these 2 points is equal to 2. So now when we look at this equation that they give us down here in part B, can you figure out how this equation here relates to this one? And so what's happening here, is how does it relate? It's just, we're just going to rearrange the terms. Okay, so they just rearranged the terms of the equation, and I'm going to show you how that happened. But so how do they relate? It's just the terms are rearranged. So what do I mean by the terms are rearranged? So let me take this and bring it down here, and let's look at manipulating this equation using some different algebra rules. So we could maybe look at this as a proportion. So we see this fraction over here. So we could put this part under 1, and then we could look into cross multiplying. Okay, so if we were to multiply this 1 up here and then multiply this whole piece up to the 2, then we would see that we end up with 1 times y minus 3 is just y minus 3. And then we'll take this whole x minus 2, or sorry, x minus 1 times 2. So I'm just going to write the 2 first, and then we're going to multiply that by the x minus 1, and I'll just put that in parentheses. And then you can see that this is the same as this equation. So we have that y minus 3 times 2, or equals 2 times x minus 1. So all we did was just rearranged those terms, and it gave us this equation. So these two equations are equivalent, or the same, just written differently. So looking at number 2 here, they give us another equation written kind of like this, or written exactly like the second one. So if we go back here, remember we had a point that we plugged in, okay, equal to a slope, and we manipulated it to look like this. So you can see that 3 being plugged in and that 1, and then the slope. So taking a look at this next equation, what point do we know is passing through this line? So what point can we steal from this equation? So the x value of this point that we plugged in was 5. And the y value that we plugged in was 7. So we know that the 0.57 is on this line, or that the line goes through the 0.57. And then the slope is the number out front here multiplied by the x portion. And so the slope here is 1/2. So we know that this line is a line that has a slope of 1/2 and passes through the 0.57. So what if we were to write a general equation for this? So now they're just going to give us a generic point, HK. So let's write an equation of a line that goes through that point and has a slope of m. So remember, our slope equation is vertical distance over horizontal distance equals our slope. So we'll put in our vertical distance, and our vertical distance, remember, is we subtract the y values. So this is going to be y minus k. I'm just going to make this black here. And then our vertical, our vertical distance is y minus k. And then our horizontal distance is the subtraction of the x's. So this will give us the width of that slope triangle. So x minus h. And the vertical distance over the horizontal distance is equal to the slope. In this case, they're calling the slope m. So this would be an equation that we could write that goes through the point HK and has a slope of m. And again, taking a look at this one, okay, this is just, again, rearranging the terms. So if we take this equation here and we just rearrange those, we just rearrange those terms like we did on the last one. Bear with me. I grabbed too much. All right, just this part. All right, so if we took this part and we just rearranged those terms, right, so we could look at it as a proportion again, and we could do cross multiplication. So thinking of a 1 under there, and then we could just multiply the 1 times the y minus k, and we just get y minus k, and then equals, and we can take this x minus h and multiply it times the m. So we'll just end up with m times the x minus h portion. So we know then that this is an equation that will work for us to write a line when we know a point. Okay, so HK is a point that we know the line is going to go through. So we know HK is on the line, and we know that the line has a slope of m. All right, so let's discuss this. So what set of points does the equation y minus 3 equals 2 times x minus 1 represent? So what point does this go through? And what's the slope? So this point, okay, 1 is the x coordinate, 3 is the y coordinate, and our slope is 2. So the set of all points that goes through the point 1, 3 and has a slope of 2, that is the points that this line represents. Okay, all the points that go through the point 1, 3 with a slope of 2. Then this equation that we just looked at is actually called point slope form. So that's what it's called. What do x, y, and hk and m, let me make that green, represent? So what do those different things represent? So remember, HK is a specific point that we know. Okay, so this point HK, we know that this is on the line. Okay, this is given to us. XY is just any other point. And M is our slope. So XY is any point that's on the line. HK is the one that we know or we're given. And then M is the slope of the line. Why do we subtract the K from Y and the H from X? So do you remember why we did that? So remember that this Y minus K was the vertical component of our slope triangle. So if we just kind of look at this as a line, remember that Y minus K represented this vertical distance on the slope, and the X minus H represented our horizontal distance. So the Y minus K is the rise, the X minus H is the run, and rise over run gives us the slope. And then do you remember two other ways that we've written equations of lines before that you've seen others written besides point slope form? So two ways you might remember lines being written is in what's called slope intercept form and standard form. So these are two other ways you might have seen equations of lines written. Slope intercept form is when we know the y-intercept. So we know that this b value is where it crosses the y-axis, and then we still have the slope. And then standard form is when we have the x and y on the same side of the equal sign equal to just a constant number. So if I did a couple examples of this, this would be like y equals 1/2 x plus 7. Okay, this could be like 3x plus 5y equals 10. All right, then on page 70, let's take a look at point slope form a couple more times here. So let's write the equation using point slope form. So you see it in the corner of the screen here. And let's write the equation of a line with the given information in each of these. So why don't you go ahead and try it? So just plug these things in, and then you can come back to the video and see if you did it correctly. All right, so when I'm doing this, I like to write out the point slope form and just leave these colored spaces blank and then just fill them in. So y minus, and then I leave a blank for the y coordinate, equals, leave a blank for the m, parenthesis x minus, and leave a blank for the x coordinate. So I'm just going to put that in each of these. So it'll be y minus the y coordinate equals the slope times x minus the x coordinate in each of these, and then we can just go ahead and fill it in. So we always do y minus the y coordinate, and so the y coordinate of the point that we know is 8. And then we will do equals the slope, so 4/5 times x minus the x coordinate. So remember, this is minus, and you can do -2 like this, or minus a minus. I like to do my -2 like this, where I put -2. So now I know that that's x plus 2. So do it again for the next one. So y minus the y coordinate. So y minus 7 equals the slope. So the slope is -7/3 times x minus the x coordinate, and the x coordinate in this one is 0. So we could rewrite this one if we wanted to kind of clean it up a little and just say y minus 7 equals -7/3 x, because x minus 0 is just x. Next one, y minus the y coordinate. So y minus 0 equals the slope, which is -1, times x minus the x coordinate, which is 12. And now for this one, you could do y minus 0 as y, so you could just rewrite this as y equals, and you don't even have to put the 1 here. You could just do negative x minus 12. But it is kind of nice to have the 1 there so you remember that the slope is -1. Now in this last one, we've got a bunch of different points here. You can choose any of them. So we've got kind of 5 different points highlighted here. Choose any one you want and plug it in. Okay, so you'll do y minus whatever the y coordinate is, and then you're going to have to find the slope, and then x minus the x coordinate. So go ahead and count the rise over run. So up 1 over 2. So your slope is 1/2. And then plug in, so choose whatever point you want. Okay, it doesn't matter. So if I choose this one, 2, 3, we will take and do y minus the y coordinate and x minus the x coordinate. So let me do one other point on here. So let me do maybe this one right here. So this point right here is -2, 1. So we will do y minus the y coordinate, so y minus 1. Slope of this line is still 1/2. And then we'll do x minus the x coordinate. And now the x coordinate is -2. So this equation would be y minus 1 equals 1/2 times x plus 2. You could have plugged in any of those 5 points. Then let's take a look at some that are already written and just figure out the order or the point that it goes through and the slope. So the x coordinate here, in order for this to turn to +4, we plugged in a -4. So the x coordinate is -4. The y coordinate, we plugged in 5. So -4, 5 is the point. Slope is 3/2. For this next one, we've got the slope, since I already have my green marker. Okay, the slope is 5. The x coordinate, so what did we subtract from x? Well, we subtracted 0. Whoops. Okay, we didn't subtract anything from x, so we subtracted 0. So the x coordinate is 0. The y coordinate in this one, -2 in order for that to turn to +2. Third one, okay, we see the slope here of -2. X coordinate, so what did we subtract? We subtracted 5/8. And then what did we subtract from the y? So nothing, so 0. All right, then given this line here, okay, what are some things you notice about it? And then can you write at least 3 equations of the different lines here? So write 3 equations of the different lines that you see. So go ahead and try that. So hopefully you notice that all of these lines here go through this same point. Okay, so all of these lines go through the point 4, 2. And then you just have to figure out slope so that you could write the equations of them. But every one of these lines would start with, okay, so if we did the point slope form, we'd have y minus the y coordinate, which is 2. Okay, all of these lines go through this point, equals the slope times x minus the x coordinate of 4. So then you'd be able to look at any of these lines up here and determine their slope and just plug it in here. So what are some different slopes that you see for these lines? So if we looked at this yellow one, okay, we could count up 1 over 3. So for the yellow line, the slope would be 1/3. So that would be an equation for that line. So this is for the yellow line. Okay, let me get that out of there and just group this so I can copy it. So now if we did another line, okay, so this was for the yellow line. So if we took a look at maybe this red line here and we counted the slope, so let's find a point here. So it's here, and then we can count up 3 over 1. So the slope of that red line is 3 over 1. So a slope of 3, this would be the equation of the red line. And so on. You could do others. So what would the slope of the blue line be? Whoops. So we've got this blue line here. So down 1 over 3 for that one. So this has a slope of -1/3. So that blue line has a slope of -1/3. Black line. But notice that they all have the same point that they're going through. So I don't have to keep plugging in a different point because I already know that it's all going through the point 4, 2. So if we took a look at the black line, here's a point that the black line starts at. So down 3 over 1. So down 3 over 1 would be a slope of -3 for that black line. And then you see a horizontal and a vertical line on there. So this horizontal line right here, the slope doesn't go up at all. So it's a rise of 0. So the slope is 0 for that green line. So we could plug in here and put 0 in for the green line's slope. And then this light blue line is different because the slope is undefined. Okay, a vertical line, the slope is undefined. So this one just has an x value. So x equals 4 would be the line for that one since the slope is undefined. It's a bit different. All right, then this can go on your reference chart. So this is the point slope form. So remember, HK is a point that we know is on the line. And then M is the slope of that line. And then here's your summary. So remember that a line can be defined as the set of all points. So this line in this image is the set of all points with a slope of 2 that goes through the point 3, 4. So the slope formula would be the vertical distance divided by the horizontal equals the slope, which manipulated gives us this equation in point slope form. So remember that point slope form is what we looked at a lot today. So here's point slope form. I just kind of highlighted some of the different things. XY is any point on the line. HK is a point that we know that's given to us. M is the slope. We also have seen slope intercept form in the past. Y equals mx plus b. Also standard form, ax plus by equals c. If you are given 2 points, okay, on a line, so if you're just given 2 points, you would first, okay, so number 1, to write the equation of the line, you would need to find the slope. Okay, so number 1, you would find the slope using slope formula, so subtracting the y's to get the vertical distance, subtracting the x's to get the horizontal. Then you would choose any point. Okay, so number 2 would be choose any point to use as HK, so either one of these. And you would just plug all of that into point slope form. All right, then here's your cool down. You can try this cool down. If you're having trouble with it, be sure that you reach out to your teacher to ask for help.